Hello and welcome to our fourth video on Advanced Trigonometry. Before you begin this video, I suggest you go and watch our videos on trigonometry recap because they are really important skills that you're going to have to use for this video. So if you are happy and confident with trigonometry, we'll begin this lesson. So to start off with, I'd like you to look at these two triangles and tell me as much information as you can. Try and fill in as much information as you can. Have a pause of the video and try and do that. Okay, so let's go through this left-hand triangle. We'll look at this left-hand triangle. So to begin with, we can fill in the really easy information. These lines that are on each of these sides represent that they are the same length. So you can put in the value of this base of the triangle, which is 1. We also know that angles in a triangle add up to 180. So if this angle is 90, and we have a 45-degree angle as well, that means the top missing angle must also be 45 because we need to make sure that they sum to 180. Now we've got one side missing, the hypotenuse is missing, and we need to try and work that out. So we're going to use Pythagoras to try and work that out, which gives us root 2. So the missing length is root 2. So now we know all of the lengths of this triangle. And now we're going to try and work out some trig ratios from this triangle. So we'll start off with sine. So we know sine is the opposite divided by the hypotenuse, and we're going to label it with regards to this bottom 45-degree angle. So we're going to use this angle. It doesn't matter which angle we use. I just chose to use this one. We could have used the top one as well, but we're just going to use this one. So first thing we're going to do is label the triangle. Once again, we know the hypotenuse is opposite the right angle. The opposite is opposite the angle given, and the adjacent is the one left over. So once we do this, we can start substituting in the values. So I know my angle is 45, I know my opposite is 1, and I know my hypotenuse is root 2. Now we have this fraction. This fraction is the exact value of sine 45. So if you have the sine of an angle 45, it's always going to give us 1 over root 2. Now this is not an acceptable answer to give. We'd need to rationalize this, which would give us sine 45 giving us root 2 over 2. Root 2 over 2 is what the value of sine 45 is. We can do the same thing for cosine. Same thing for cosine. We're going to label the triangle with regards to this 45-degree angle. We are going to substitute in the values, and once again we've got 1 over root 2. 1 over root 2 is not an acceptable fraction to give, so we need to rationalize this denominator, which gives us root 2 over 2. So we've done sine, we've done cosine. Sine of 45 is root 2 over 2. Cos of 45 is root 2 over 2. Now we need to do tan. So tan, once again, opposite over adjacent. We substitute our values in. There we are. We get 1 over 1. Opposite is 1, adjacent is 1, which means tan of 45 is 1. So these are the exact values when we have a 45-degree angle. When we have a 45-degree angle. Now we can do this for a couple of other angles. So we're going to be looking at the other triangle that I had on there, the equilateral one. So this triangle here. The issue with this triangle is that we can't exactly apply trig to it as is. But before we do that, we just need to make sure we've got all of the lengths of all of the sides. So these lines, once again, denote that all of the lengths are the same size. So we know all of them are going to be 2. That could be 2 units, 2 centimeters, 2 meters, does not matter. They are just 2. They're the same value. We also know that because this is an equilateral triangle, that all of the angles must be the same, which means they would be 60, because angles in a triangle sum to 180, and 180 divided by 3 is 60. So we have this. But as I said earlier, we still can't apply Pythagoras or trigonometry. So what we need to do is try and create a right angle triangle. So we've drawn in a perpendicular line there, which creates a right angle triangle there. There's our right angle triangle. Now, because this right angle triangle isn't the same as the original one we had, we have to try and change some of these lengths that we have and some of the values that we've got on this triangle. So the bottom value here, the base of this triangle, is going to be 1 because we cut the triangle in half. It was 2, it's now 1. This side, we haven't done anything to, so it's still going to remain as 2. This angle, we haven't done anything to, so it's still going to remain as 60. The top angle we cut in half. We bisected that top angle, which means that that top angle becomes 30. So we now have this right angle triangle. we can just double check that the angles add up correctly. So 30 add 60 is 90, add 90 is 180, so that works. We've just got this missing height. And once again, we're going to use Pythagoras to work out that missing height, which gives us a height of root 3. So now we're going to use this triangle to try and do the same thing we did before. But first, we're going to pick which angle to start with. So we are going to start with this bottom 60-degree angle. That's the angle we're going to work with. So we're going to work out sine of that angle. So once again, we write the formula down. We label the triangle. So there's our angle. There's our 90 degree. 90 degree, opposite the 90 degree is the hypotenuse. Opposite the angle is the opposite. And then the one left over is the adjacent. We substitute our values in. Now this fraction is completely acceptable. We do not need to do anything else with it. So we can just say that sine of 60 is root 3 over 2. We do the same thing for cosine. Once again, label the triangle. It's really important that we label the triangle so we know which values to substitute in. Substitute in the values. Once again, this is a very acceptable fraction. It's a very nice fraction. It's a half. So we end up with cos of 60 is a half. And lastly, we're going to do tan. Write down the formula. Label the triangle. Then substitute our values, and we get root 3 divided by 2. No, sorry, root 3 divided by 1, which means we get tan 60 is just root 3 on its own. So now we have 45 degrees, we've got 60 degrees. And we can also do 30 degrees because our triangle has a 30-degree angle in it. Triangle now to work with this 30-degree angle. So that's the angle we're working with. And once again, we're going to do the same thing. We're going to start off with sine. We write the equation. We label the triangle. We're starting to understand some steps that we need to do. Writing the equation, labeling the triangle. This will make sure you're less likely to make some mistakes. Substitute in our values. We look at the answer that we get. Sine 30 is equal to a half. Is a half an acceptable fraction? Yes, it's completely acceptable. So we know sine 30 is a half. When I say acceptable, I mean, is it a fraction that we would write? Previously, we've had some fractions that give us surds as the denominator, in which case we'd have to rationalize it. For this particular question, for sine 30, we don't get a surd as a fraction, so we're okay in that regard. We're now going to do the same thing for cosine. Label the triangle, substitute in our values, decide whether or not the fraction is acceptable, write it down. Cos of 30 is root 3 over 2. And tan, if you have a look, we get 1 over root 3 because the opposite and adjacent have swapped over. The opposite is now 1 and the adjacent is now root 3, which means that this fraction needs to be rationalized. So we'd write it as root 3 over 3. So we've got this one. So if we were going to show this in a table so you have all of them together, it would look something like this. It's really important to note that sine of 30 and cos of 60 are the same. Sine of 60 and cos of 30 are the same. That's because cosine is the complement to sine. These two ratios are interlinked. We can see that. 45 degrees, they're the same. So it's really important to notice that, well, sine of 30 and cos of 60 are basically the same. They're in sense opposites. As one is tending towards 1, the other one is tending towards 0. Right, we're going to look at the rest of them that we need to work out. We need to work out 0 and 90. Unfortunately, we can't do that on a triangle, and we're going to have to use the unit circle again. And here we are with our fantastic unit circle. Just a reminder, the unit circle is a circle on a graph where the center is 0, 0 at the origin. The radius is 1, and we can use this to try and work out trig ratios, the value of trig ratios. So let's have a look at this first one. So we're going to make the angle 0. We're just going to make the angle 0. As you can see, as we're making the angle 0, the adjacent is tending towards 1, and the opposite is tending towards 0. So the opposite's getting smaller, but the adjacent's getting bigger until we get to this point here, where we get to 1. Now we're going to do some trigonometry to apply to this, so we're going to have a look at what happens. So we're going to do sine of 0. Well, sine of 0 is the opposite divided by the hypotenuse. The opposite is currently 0. The hypotenuse is currently 1. So sine of 0 is 0 divided by 1, which gives us 0. We're going to do the same thing for cosine. The adjacent is currently 1. The hypotenuse is currently 1. And cosine is adjacent divided by hypotenuse. So we end up with 1 divided by 1. So cos of 0 is 1. And we can see that this length that we know gives us the cosine value is also 1. We're going to do tan now, where we do the opposite divided by the adjacent, which is 0 divided by 1, which gives us 0. So we have sine of 0 is 0, cos of 0 is 1, tan of 0 is 0. So now that we've done that, we need to try and make a 90-degree angle. So I'm just going to make this a 90-degree angle. And as you can see, the opposite is now tending towards 1, and the adjacent is tending towards 0. So I'll make this 90-degree angle. There we are. And we can see that we have some slightly different answers. We end up where we have sine, we have the opposite, which is 1, the red line, divided by the hypotenuse, which is 1. So sine of 90 is 1. Then we have cosine of 90, where we have the adjacent is 0 and the hypotenuse is 1. So we have 0 divided by 1, which gives us 0. So cos 90 is 0. Now, tan 90 is very interesting. It says undefined. And that's because our adjacent is 0. So we end up with 1, our opposite, 1, being divided by 0. And we cannot divide by 0. So we end up with an undefined answer. This value does not exist. An exact value for tan 90 does not exist. And it will make more sense as we go on through the lessons. There will be another lesson explaining this a bit more in a bit more depth. But we can see that because we end up dividing by 0, tan of 90 is undefined. So now we can finish off filling in our table. So we've got sine of 0 is 0, cosine of 0 is 1, tan of 0 is 0. And we've got sine of 90 is 1, cosine of 90 is 0, and tan of 90 is undefined. We have all of these values, and these are our exact values of trigonometric ratios. This is a non-calculator skill that we have just done. So you will know if you ever see sine 30, you know the answer is going to be a half. Always, regardless of the triangle. If we ever see cos of 60, the answer is always going to be a half. If you see sine or cosine of 45, the answer is going to be root 2 over 2. Tan of 45 will always be 1. It's really important that we get to grips with these numbers and get used to seeing them and become familiar with them. Some students like to memorize this entire table and be able to regurgitate it from their mind at any point. I don't suggest that. There are a lot of numbers. They can get confusing because some of the numbers repeat. So what I suggest you do is learn how to manipulate these two triangles. This is significantly easier to do than learning all of these values. Being able to manipulate these two triangles is significantly easier. That's what I believe. If you're confident in your basic trigonometry, once I can say it eventually, if you're confident in your basic trigonometry, manipulating these triangles is very simple. And I would suggest doing that rather than memorizing them, because you're very likely to forget. So hopefully that's been helpful. This has been the video on exact values of trigonometry. Feel free to go and try some questions. Mr. Amison has also uploaded a video which I will link that you can go and watch, and that will help you practice these skills, practice using the exact values and doing this without a calculator. What I suggest is, if you are one of those people that wants to do some practice, what I suggest is having this with you to begin with. So having the table with you to begin with, and then slowly removing the table away from yourself. So to begin with, have the table readily available just so you can look back to it and refer to it. And as you do more and more questions, stop looking at the table as much until you can get to a point where you can answer exact value of trig questions without remembering the table. However, if you still need to draw the diagrams, that's perfectly fine, and I actually suggest drawing the diagrams to help you remember. Hopefully that's been useful, and go forth, do some practice on Corbett Maths or Dr. Frost, go off and be productive, and I'll see you in the next video.